Now that we've learned how to make alkynes, let's see how we can get rid of them. We can reduce alkynes using hydrogen and platinum in the same way that we reduce the alkenes, double bonds. And what we get is 100%. It's very difficult to isolate the intermediate alkene. So in order to do that, we use a poisoned catalyst. It's called a Lindar catalyst, or we can use a nickel bromide compound. This makes the cis form only. So if we have this alkyne down here and we use the Lindar catalyst, we would expect to get a cis double bond in here in place of the triple bond. And the way I usually draw these is I will draw the cis first, and I'm going to number the carbons 2, 3, 4, and 5. And then we know that the triple bond is between 2 and 3, so this is 2 and that's 3. This must be 1 then. So this is 4, and this is 5. Off the fourth carbon, we've got a methyl group, so we draw that. And now you've got your compound. Numbering them is important or helpful. Okay, if we treat it with hydrogen and platinum, we'll expect to get rid of all the double or triple bonds, and we'll get a compound that looks like this. It's a pentane with a methyl group at the fourth position. Okay, so sometimes we don't want to have a cis bond, so we have methods to produce the trans. If we take sodium and dissolve it in liquid ammonia, we find that we'll get 80% of the trans form. In this case, sodium is serving as a source of electrons. A single electron is transferred from the sodium to the carbon atom, and one of these pi bonds gives one electron here and gives the other electron to the other side. So we have a single electron on one side and a pair on the other. The electrons that are on this carbon are then going to snatch a proton. These electrons will then go to the nitrogen. Sodium then donates a second electron so that we get a pair. The pair of electrons are then able to snatch a proton from the ammonia, giving us our product that is trans in nature. You'll notice that the trans is lower in this form here, particularly, is lower in energy. If you try to make this form, where we've got 2 electrons here and 1 here, we get a lot of repulsion between the 2 groups. And so the trans form is favored. So let's look at some examples. We'll draw the major products produced. Again, you're going to find me numbering the carbons because it's really easy to lose track. You should have 6 carbon figure when we get done, if we did it right. So it's going to look like that. We know that the double bond is going to be between the second and the third. So it's going to be here, and it's going to be trans, because we treated it with sodium in a liquid ammonia. Let's look at the next one. 1, 2, 3, 4, 5, 6, and 7. So we're going to end up with a 7 carbon. And we're going to have a methyl on the second one. So there's a methyl on the second one. And the 6th one has 2 groups on it. And the double bond is going to be trans, and it's going to be between the 3 and the 4. There's 1, 2, 3. So our double bond is going to be right there. Catalytic hydrogenation versus dissolving reaction. So this is just a summary of what I've just been talking about. If we have a triple bond and we treat it with a poison catalyst, we'll get a cis form. If we further treat that with hydrogen with platinum, we'll get an alkane. We can do that directly with hydrogen and platinum. If we want the trans form, we have to use the sodium in liquid nitrogen. So let's identify the reagents we would use to achieve the following transformations. This might be a good time for you to stop the video and see if you can figure it out. So doing these practices at the end of each section are a good way to see how much you've actually retained. All right, so this first one is going to be a cis. So we know we want a poison catalyst, and we'll use Lindars, and we'll have to have some hydrogen in there. Here we have a trans, so we'll be using the sodium in the liquid nitrogen. In the liquid ammonia. I think I said nitrogen before too. That's ammonia, obviously. Okay, if we want a trans, like this one, again, we'll use sodium in ammonia. And if we want to get rid of all the double bonds and triple bonds, we'll use hydrogen and a platinum catalyst.